Okay, so now we're going to look at factoring polynomials, specifically trinomials, when the leading coefficient is larger than 1, okay? So you can't quite, you can't do the A&M method here. If you try, it won't work. You might think, oh, it's 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. You can go ahead and try it. It's not going to work, and the reason why is because of this guy in front right here. Now, there's two ways to go about this. You can do guess and check, which I'm not actually a big fan of that. I am going to show it to you though because it's a fairly quick way of doing it, but most students don't like it because it's what you're doing is you guess and then you check it, and if you're wrong, you can get a little frustrating. So let me show you guess and check real quick, and then I'm going to show you kind of more of a step-by-step way of doing it. So if I'm gonna do guess and check, if you remember, so you're trying to figure out when you have two binomials, you're trying to figure out the first two that multiply to give you that first term right there, 2x squared. In this case, there's only really one option. It would be 2x and x, okay? Um, and in other problems, if that were like let's say it was a 12, let's say it was a 12, that would be really hard because is it 4 and 3, 2 and 6, 1 and 12? But for our particular case, it's a 2x squared, so that's not too bad. So the guessing part hasn't really been all that bad. Then what we have to do is figure out the last part. What multiplies to give me 6? Now, the difference here is the outer and the inner, right, have to add up to 7x. And so that 2x makes things different from what we'd done in the previous section. So numbers that multiply to give me 6 would be 6 and 1, 2 and 3, right? And so I got to figure out where to put them. And right now everything's positive. So once again, that kind of makes this a little bit easier because I know I'm only dealing with positive numbers. But let's see, I'm just going to guess. Let's see, I'll put a plus 1 here and a plus 6 here. That's not going to work because first of all, this is 12x, that's 1x. That adds up to 13x, not 7x. So that's not going to work. So we go ahead and erase that. So see, you guess, you check, and it can get a little frustrating. So then you can switch it. You can put the plus 6 here and the plus 1 here. Let's see, I get closer, but not there, because that adds up to 8x, not 7x. So let me go ahead and delete that. Okay, so let's go ahead, let's see, 2 and 3. Let's see, I'm going to put the 3 here and the 2 here, and I think this time I'm right. So let's see, that'll give me a 3x, that will give me a 4x, and when I add them together, it's 7x, and so this is my actual answer right there, okay? Now, if you feel overwhelmed, that's understandable, okay? That's guess and check. Like I said, I'm not actually really a big fan of that. I'm going to show you a different method that I've kind of developed over the years. Now, it's not like I made it up. I've seen it in books, and I kind of basically just put it in my own words. So I kind of put it the way it makes sense to me. And so hopefully that will translate over to you. Now, just to let you know, it's going to take a couple examples until you really feel like you've got this down. But once you've got it down, students always tell me like, "Oh, it's easy. I can do it, no problem." But the first time you see me do this method, you're going to kind of be like, "Huh? What?" But let's do it a couple times, and then you go practice it on your own, and I promise you'll get it down. It's not that big of a deal, but it is important for college algebra. That's why we're going to work on this so much. Okay, so I have the same exact problem right here, 2x squared plus 7x plus 6. Okay, this is the way I like to do it. I call it factor by grouping. Like I said, other books do something similar to this, okay? But this is just me kind of putting it into my own words. So step one, all my steps are fairly simple. Step one is multiply the leading coefficient and constant together. So what that means is this is the leading coefficient, this is the constant. So basically multiply the edge numbers together, the outside numbers on each side. So 2 times 6 is 12. That was step one. That's not that difficult. So 2 times 6 is 12. Okay, my next step is, and this is going to sound kind of confusing, but once we do it, it's not challenging. Find two numbers such that the product is equal to the result from step one, okay, but also adds up to the middle value. Also adds up to the middle value. So basically, I'm looking for two numbers. I'm going to call them A and B. Okay, so I'm looking for two numbers. Just I'm calling them A and B. I could call them X and Y or whatever I want. I just happen to call them A and B here. I'm looking for two numbers that multiply to give me the value from step 1. And they also at the same time have to add up to the middle value, which in this case is a 7. Okay, so multiply to give me 12, but add up to 7. Kind of similar to what we did in the previous video. The difference is I had to multiply the leading coefficient by the back number first, right? Okay, and so those two magic numbers are going to be 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. Now, what I'm going to do here is this is step 3 now. Okay, so I'm done with step 2. Step 2 is just coming up with those numbers. Step 3 is that we're going to replace the middle value with the two values from step 2. So what we're going to do is we're going to replace 7x with a 4x plus 3x, because that's the same thing. 4 plus 3 is 7. 4x plus 3x is 7. It's the same thing. But now what that will allow me to do is I'll be in the factor by grouping format now. I'll have 4 terms. So I group the first two, group the second two. Oh yeah, by the way, in case you're wondering, it doesn't matter which one goes first. I could have put the plus 3x and then the plus 4x. It doesn't make a difference. Okay, so group the first two, group the second two. On the first two, I can factor out a 2x, so I do that. On the second one, I factor out a 3, so I do that. And then you notice I do have common factors right here. I do have the x plus 2, and so I'm going to factor that out. On this particular example, I factored it out to the back side. It doesn't matter. I could have factored it out to the front. But anyways, what's left behind is the 2x plus 3 right here. 2x plus 3 is right there. Doesn't matter what order you write them in. You could put the x plus 2 first. It doesn't make a difference. Okay, and so if you FOIL it back together, it would go right back to where we started, but this is our actual answer right here. That's us factoring it, okay? So, yeah, you might be kind of like, wow, that seems like a lot. To be honest, it's really not that bad, and once you do a couple of these, you'll fly through them. It's not that big of a deal, okay? You just have to recognize when you need to use this approach, okay? And so this approach is when the leading coefficient is something other than 1, okay? If it's just an x squared, then just go back to your normal methods that we've been doing, okay? But once you throw a number in front, it does make the situation a little bit more complicated. Okay, so on this first one, what I'm going to do here is the step 1 is multiply the outside numbers, right? The leading coefficient by the constant. Now, I do have to take the sign with it when I multiply, so that's going to give me a -6. That's step 1. That's not too bad. Okay, step 2 is now I got to figure out two numbers, I'll call them A and B, that multiply to give me -6 from step 1. But also add up to that middle value right there, -1. So they have to add up to -1. Now, what I know about those numbers is one's got to be positive and one's going to have to be negative in order for the product to be negative, and then same thing for them to add to be a negative. So I believe it's going to be a -3 and a +2, right? -3 and +2. -3 times 2 is -6. That adds to -1. So now I'm going to have to split. What I'm going to do is replace this basically with a -3x and a +2x. So everything else stays the same. So my edges, nothing changes with those, okay? So I still have a 3x squared. Now I'm going to replace the middle with a -3x and a +2x. And then I still have the -2 on the back end. So I took that and replaced it. It looks different, but it's equivalent. It's equivalent. -3x plus 2x is the same thing as -1x. Okay, the hardest part's done because at this point you should be pretty comfortable with your factor by grouping. We've done quite a bit of that. So I'm going to go ahead and by the way, I put -3x first. I could have put +2x, and I'll do it a second time with those switched just so you can see in just a minute. So on the first one, I'll go ahead and pull out a 3x, and let's see, that'll leave me with x and then -1. Okay, so when you factor that out, you're basically dividing, right? So that turns into a 1 right there. and then I'm going to factor out or divide out a 2, and that will leave me with an x minus 1. Then I have those common factors of x minus 1, so we'll go ahead and factor that out. And then let's see, I have my 3x plus 2 as my other factor, and done. And if you want to, you can FOIL it back together. You would see that the inner and the outer add up to that negative 1x. The first two multiply to give you 3x squared. And then the last of each binomial multiply together to give you that minus 2 right there. Okay. Now, let's say that just so you can kind of see this from another perspective, what if I would have put the plus 2x first and then the minus 3x and then minus 2? It's going to look a little different as we work the problem, but we're going to get the exact same result. So on the first one, I can factor out an x, so we'll go ahead and do that, and that'll leave me with 3x plus 2. On the second one, oh, that's weird. Okay, I got a minus 3x minus 2. I need positive 3x plus 2, so I'm going to divide out a negative 1, because that will cause a sign change, right? So I'm going to divide out a negative 1, and let's see, that'll give me positive 3x plus 2. And once again, I got matching factors. This time it's 3x plus 2. And then the other factor is going to be an x minus 1. Okay, so you can see they're both the same. The factors just came out in a different order, but that doesn't make a difference. All right, so we'll get plenty of practice here. So I got another one for us to tackle. So let's see, we'll go ahead and do 6 times 4. So multiply the leading coefficient by the constant is 24. Step 1, pretty simple. Step 2 is probably the biggest step right here. So we got to figure out two numbers that multiply to give us the value from step 1, but at the same time add up to our middle value right there, the coefficient of my x. And so let's see, multiplies give me positive 24, but adds to a negative. That must mean that they both have to be negative. And I believe it's going to be a negative 3 or negative 8, negative 3, same thing. So negative 8 times negative 3 is positive 24, and that adds up to negative 11. So what I'm going to do is I'm going to replace that minus 11x with a minus 8x minus 3x. Once again, whichever order you want to list them in, it actually won't make a difference at the end. Okay, and so at this point, everything should be familiar to us as far as the last step, which is factor by grouping. So we're going to take out a 2x, and let's see, that'll leave us with 3x minus 4. And then, oh, I got minus 3x plus 4, so we'll pull out a negative 1. That'll give us a 3x minus 4. And then we'll go ahead and factor out that 3x minus 4. Put that over here. So 3x minus 4, and then my other factor is 2x minus 1. And there we go. And you can always check it by foiling it back together. That, that won't take you more than 15-20 seconds if you want to do that, especially if this is still kind of new to you. All right. Look at our next one. So step 1, multiply the edges. 4 times 15 is 60. And then step 2, find two numbers that multiply to give you 60, but add to give you 16 in the middle. So let's see, 60 divided by 2 is 30, so 30 times 2, but that adds to 32. Let's see, 60 divided by 3 is 20, but that adds to 23, and so on. So you just keep trying, and if you need to, use a calculator, but eventually you're going to get to divide by 6, and you get a 10. So 10 times 6 is 60, and that adds to 16. That's what we're looking for here. So we're going to replace that with a 10x and a 6x. So let's see, we've got 4x squared plus 10x plus 6x plus 15. And then we're going to go ahead on the first set, we can factor out a 2x. And that'll leave us with 2x plus 5. And then on the second set, we'll pull out a 3. Now will leave us with a 2x plus 5. And so now we're going to factor out the 2x plus 5. And what's left behind is 2x plus 3. And there we go. Okay. All right. Like I said, the more practice you get, it's gonna come fairly simple. And like I said, don't, on our first unit, I tried to get y'all not to use too much of the calculator, but at this point, it's fine. Use your calculator to help you out here. So let's see, 9 times 2, let's see, that's 18. And then we want to figure out what multiplies to give you 18, but add to give you -9. Okay? All right, let's see. Well, they're both going to have to be negative, right? And so it should be a -6 and a -3, right? -6 times -3 is positive 18, and that adds to -9. So that's what we're going to replace here. So we still have the 9x squared. Doesn't matter which one I put first. So minus 6x minus 3x, and then I get a plus 2 right here. And then let's see, on the first set, let's see, I can factor out a 3x, and that will leave us with 3x minus, let's see, 2 when I divide that out, right? And then let's see, I have a minus 3x plus 2, so in this case, we'll pull out a -1 to cause the sign change. And you can see if you distribute it back, you'd be right back to where we were. We don't want to do that, but we want to make the connection, though. All right. And so then from here, we'll factor out the 3x minus 2, and then we're left with 3x minus 1. Okay? So these really haven't been too bad because, I mean, they can get worse. The numbers can get larger, and I think we're about to see one like that. But let's see. I think I got one more here for us. Yeah, one more. So you can see the numbers are getting a little bit bigger. And then we'll cap this video after this question, and then I'll make a part 2 for the stuff down here. Okay, so yeah, 20, if you're trying to do guess and check, the problem with that is it could be 4 and 5, 2 and 10, maybe even 1 and 20, right? So guess and check can get very frustrating when the numbers start to get a little bit larger, especially that front number, okay? So I'm not going to do that. If you want to try guess and check, you're more than welcome to, but I'm going to go ahead and follow our method. So 20 times -8 is negative, let's see, 160. Okay, not bad. Like I said, use your calculator if you want. And so then we're going to figure out what multiplies to give me -160 and add to give me 27. So we wanted to add to give me 27, right? Okay, so I'm going to go ahead and pull my calculator out. And so let's see, 160 divided by, kind of silly to start at 2, but I can go ahead and do that. So 2 and 80. So 2 and 80, and the 2 would have to be the negative part, right? Because it needs to add to positive 27. Well, obviously, that does not work. And so let's see. I can try, let's see, clear this out. Let's see, so 160 divided by 3. Well, it doesn't even divide evenly, so don't even worry about that one. Let's see, 160 divided by 4 is 40. So 4 times 40. So 4 and 40. And so the negative value would have to be the 4, but that adds up to 36. So that's not going to work. So let's try divide by 5. So divide by 5 is 32. So 5 and 32. And so the 5 would be negative, and that looks like a winner because this right here adds to positive 27. It obviously multiplies to give me -160. So I got my winner. Okay, so we're going to go ahead and split this. And so I still have the 20. Oops, let me clean that up a little bit. So I still have my 20x squared. It doesn't matter which one goes first. I'll put the -5x and then the plus 32x, and then I have -8. And so on the first set, I can pull out a 5x. So we'll go ahead and do that. So divide out, right? So I divide, so that would turn into a 4. The x squared would go down to a 4, just x. And then 5x divided by 5x is just 1, right? And then looking at that, I got to get that matching up here. And it looks like I'm going to have to divide by 8 on both of these. So I'm going to pull out an 8. So I factor out an 8. And that will give me 4x, let's see, minus 1 right there. Okay. And then from here, we just factor out the 4x minus 1, and I should be in pretty good shape. Let me clean this up a little bit. All right. So over here, let's see. So I'm going to factor out the 4x minus 1, and what's left behind is 5x plus 8. 5x plus 8. And there we go. And if you want to, you can FOIL it back together, and you would see it goes back to where we started. But this is our answer right here. And so, you know, it's going to take practice, but once you do this enough times, it becomes like muscle memory. But the main thing is just remember, if there isn't a number in front of x squared, there's an understood 1. Those problems are actually pretty simple. Those are the ones we were doing previously. It's when we throw a number in front that can make it more challenging, okay? Okay, so I'll go ahead and stop the video here, but I'm going to have to make a part 2 where we look at some of our special cases with these.